Hello, geometry students. Today we're going to talk about how you can prove triangles are congruent. Previously, we talked about how the only way you can prove two polygons are congruent to each other is to show every corresponding side's congruent and also every corresponding angle's congruent. You have to show all of this in order to prove polygons are congruent. But I'm going to show you 4 shortcuts for how to prove triangles are congruent. Today, here's the first one. It's if 3 sides in one triangle are congruent to the 3 sides in another triangle, then you can say the triangles are congruent. You don't even have to know anything about the angles. It's a shortcut. So here's an example of how you'd use it. When you're asked the question, hey, can you prove these 2 triangles are congruent? Can you prove JAK, this triangle's congruent to NAK? Well, there are 2 things you have to do to start with. You have to first look at the given information, and the given information can be given to you in 2 different places. You can be given information in a sentence. Up top, given A is the midpoint of JN. You can also be given information as marks on the diagram, so be careful and make sure to look at both places. Any information that's given to you, you can assume to be true, and you can make logical conclusions based upon that given information. So you look for your given information and then you proceed. The next thing you want to ask yourself is, what does that given information tell us? Well, we're given that A is the midpoint of JN, so we have to remember the definition of midpoint. If you don't remember it, pause the video and look it up in your notes, and then press play to continue. The definition of midpoint is a point that divides a segment into 2 congruent parts. And so since we're allowed to trust the given that this is true, A is the midpoint of JN, we now know that AJ or JA and AN must be congruent because of the definition of midpoint, that a midpoint divides a segment into 2 congruent parts. And we were already given that JK and KN are congruent. That was part of the given. Now we ask ourselves, is there anything else that we know? So pause and look at the video and then press play when you think you have the answer or if you want a clue. We see that these 2 triangles share side AK. And when they share a side, we know that any side will be congruent to its own self. So if I redrew these triangles exactly as they are, duplicating AK would be congruent to itself. So this side is the same in both triangles. So we see that this triangle over here has 1 scratch, 2 scratch, 3 scratch on its 3 sides. And this triangle over here has 1 scratch, 2 scratch, 3 scratch on its 3 sides. Okay, so now we ask ourselves, is this enough information to conclude that those triangles are congruent? Yes, it is. By side, 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 we can now state our congruency statement. Because the minute you know 3 sides in one triangle are congruent to 3 sides in another, you can pull out side, 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 and write your congruency statement. When you write your congruency statement, make sure that you have everything lined up. So I'm naming my first triangle JKA, 1 down the shared side, 2. That means I have to name this second triangle the same way, 1 down the shared side and end with 2, NKA. Okay, if you're ready to practice, then pause and practice on your own paper. If not, feel free to watch another example. So the first thing I do is I notice that this is a little trickier of a diagram. Here I have triangle NMP, and it's overlapping with triangle MOP. So one thing you could do is take a highlighter and highlight one of the 2 triangles or both of them in a different highlighter to make sure you see clearly the 2 long triangles leaning out to each side. Okay, then what are we given? Remember, we can be given words and we can be given marks on the diagram. In this case, there are no marks on the diagram, but we do notice that a side is shared. That's important from the diagram. And then we are given this information up here. So the first question is, what does the given information tell us? Well, we were given that the measurements are equal. And so we can use our definition of congruency to state that if the measurements are equal, then the sides are congruent. That's what the definition of congruency tells us. And so we can put marks. NM is congruent to OP. NP is congruent to OM. Next, we ask ourselves, what else do we know? Well, the other thing we know is that these triangles overlap. And so they both have the third side as MP. And so we can put a mark on that because MP is congruent to its own self. And in that case, we see that this triangle has a 1 scratch, a 2 scratch, and a 3 scratch. And this triangle also has a 1 scratch, a 2 scratch, and a 3 scratch. So we ask ourselves, is that enough to prove triangle congruency? Yes, it is. By side, 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 we can now write our congruency statement. When you write your congruency statement, make sure you line up the corresponding parts. So I named the first one NMP, meaning I went down the 1 scratch, across the shared side, up the 2. So that means over here I have to do the same thing. I have to do 1 scratch across the shared side, up the 2, OPM. And now you know one shortcut for proving triangles are congruent. So I will leave you with this cute kitten and wish you a great day.